definitely.
I
Started this one.
run into this every year. Everybody has trouble with linear programming.
Yeah, it's kind of
So
difficult.
let me read it real quick.
I'm sorry, go. I'm say, or yeah, can you say that again?
I'm just going to read it real quick.
Oh, okay, sounds good.
Okay.
Cool.
As soon as that stops, I can. Okay. Um,
Yeah, I'm sorry. There's a
it's all right.
guy.
No, no,
Machine's going off, and
no problem. Okay.
yeah.
What you
Uh,
end up with in
mhm.
linear programming is something called an objective function.
Okay.
Okay? Which in this particular problem is the profit. Uh,
Okay.
and let's see, the one sells for $1, the other sells for $1.50, but that's not actually the profit.
Yeah.
That's the revenue. Hold on a second. I guess they're not even counting the cost of
No.
cookies. They're assuming the cost is zero.
Yeah.
So that's all right. So that profit equation is correct. You're going to get $1 if you let's check your variables here.
Okay.
First of all, notice that you haven't spelled out a variable. You
Okay.
don't say what X is and you don't say what Y is.
Oh, I meant yeah. Top is X and then bottom is Y. I don't know why I didn't put. My bad.
That's okay. One of the key
Yeah.
parts to the first part of word problems, though, is really spelling out exactly what the variable means.
Yeah.
You'd be amazed at how much easier it becomes. Now, is
Mhm.
this the number of chocolate chip cookies sold?
Um. Yeah, it's the
Isn't
number of
it the
chocolate.
number of dozen? In other words, if we're going to give a revenue of $1, then X has to be the number of dozen.
Okay. So
See
number of
why?
dozen. Yeah, I see why.
In other words, everything's in dozens, which is 12.
Yeah.
So the
Exactly.
number of dozens of chocolate chip and
Mhm.
Y is going to be the number of dozens of sugar cookies.
Cool.
And that makes this your revenue function. Or in this case, the revenue function is the same as the profit function because they don't attach any cost to making these cookies.
Okay.
Okay? But all linear programming problems have this objective function.
Okay.
And then they have constraints. Okay? And here's what's going to happen. I'm going to graph these constraints, and I'm just going to do it real quick just so you get an idea of what I'm talking about.
Okay.
There's one constraint. There's another constraint. And what I'm going to do is examine all 4 points and plug in the X and Y value of those 4 points into my profit function and see which one gives me the greatest amount of profit.
Okay.
That's
That makes sense.
basically what you're doing with linear programming. Now, I didn't graph it properly because I didn't
Yeah.
look at it, so we need to graph it properly.
Okay.
Okay, so the first constraint is X has to be less than or equal to 50. Okay,
Mhm.
and notice everything is in dozens, so I can just make that be the case. Well, if I graph, oops, hold on.
You're good.
If I graph the line, X has to be less than or equal to 50, that's a solid line.
Okay.
Which side of that am I on?
In the cabinet, maybe?
The
Oh,
left,
sorry. Yeah.
right?
So, would those be, yeah,
That's 50 right there.
right. Would those be like the right constraints for,
Yeah, well, so far, let's see. They will bake up to 20 dozen. So, no, X has to be less than or equal to 20.
yeah.
Um,
And then I said Y is less than or equal to 40.
correct. And X plus Y has to be less than or equal to 50. So,
X plus Y.
well, let's start out by writing those constraints out again, because, yeah, you didn't quite do it right.
Okay.
So, let's see. X has to be less than or equal to, what was it, 20?
Yeah, I believe so.
Bake up to 20. Y
Mm-hmm.
has to be less than or equal to 40, and X plus Y has to be less than or equal to 50. Correct?
Okay. Yeah, that sounds right.
Okay. So
Okay,
if
that's where I
I
messed
make
up. I was,
this 20,
okay.
this,
That's where I messed up, because, like, I was, like, trying to graph it, and it wasn't working out. Like, it wouldn't make a triangle, and I was like, man.
well, the X is a vertical line
Mm-hmm.
and solid. The Y is a horizontal line and solid.
Okay.
And which side of the vertical line do I have to be on, the left or the right?
Um, you have to be to the left, because
And which
it's,
side of the vertical line do I need to be on, under or over?
under.
So at this point, our region of possible answers lies there. But we
Okay.
haven't plotted this third line yet.
Yeah.
How do I graph that third line?
Um, well, you could put it
X
into,
plus Y is less than 50.
well, you could put it into slope-intercept form. Would
Let's
that
do
be,
it. So,
okay.
and I'm going to put it there like that.
Okay.
Now, that's going to be a line with what kind of slope?
Um, that's gonna be a line, let me see. With the negative slope.
What's the size of the slope?
Um, it'd be down 1/1. Like you'd
Okay.
start at 50 and then go down.
-1 is the size of the slope. Okay.
Okay.
And I know that this line goes through that point right there, which we'll call 50.
Okay.
And it has a -1 slope. So it's going to look something like this. And now my region of possible answers has been narrowed to there.
Okay.
Okay? And I have some vertexes that I have to test. I have to test that one, that one, that one, that one, and this one. Although the one at the origin almost always is never the maximum profit. Okay?
Right.
So I'm
Okay.
going to put my profit function down here. It's equal
Okay.
to 1x plus 1.5y.
Okay.
So we'll call these 1, 2, 3, 4, and 5. And our maximum profit is going to have to come at one of those vertices. It's never
Yeah.
going to come over here in the
Mm-hmm.
middle of that line. It's always going to come at one of these vertices. And not this one. Notice this one is outside of our area.
Right.
That's not y less than 40. So
No.
let's start with 1. What's my profit with those 2 points?
Um,
In other words, we're going to say profit of point 1 is, I almost hate to do that. Yeah, well, I'll still do it.
mm-hmm.
So plug in the x and y coordinate from point 1 into your profit equation. What do you get as a profit?
So it wouldn't, how would we do that? So it would be 1 times 20 plus,
No, no, we're looking at this point right here.
so point 1.
What's the coordinates on point 1?
What would those coordinates be?
That's the origin.
Okay.
0 and 0.
Oh yeah, because that's, okay, yeah, that makes sense.
Okay?
Okay.
But when I plug them in, the profit from that point is 0. Now let's figure out the profit from point 2.
Okay.
What are the coordinates for point 2?
So the coordinates, for point 2 would be 0, 50, or, yeah, 0, 20, my bad.
0 and 20. So
Yeah,
it's actually 20 and 0.
or 20, yeah, because it's y,
You're
my bad.
right, because we got to plug the x into this part and the y part into there. So the profit for that point would be 20, correct?
Yeah,
In other
exactly.
words, we would make 20 chocolate chips and no sugar cookies, and we'd make 20 bucks. Well,
Hmm.
now let's examine point 3. Now it gets a little trickier, and this is usually in the area. Point 3 or point 4 is where I would expect to find the maximum profit.
Hmm.
Before we can get point 3, I need to figure out what its coordinates are.
Okay.
What's the x coordinate of point 3?
Um, well, the x-coordinate of point 3 would be, would that just be 1?
Right here. We have a vertical
Um,
line going through 20.
okay.
So what's the x coordinate of that?
The x-coordinate would be, um,
20. It has to be 20.
just 20.
Yeah, the x coordinate all along this vertical line, the x coordinate is 20. No matter where
Okay.
you're at on this vertical line over here.
Okay.
Okay. So
Okay.
the x coordinate is 20, and now plug, since that point is on that slanted line, it has to satisfy this inequality. So if I plug
Right.
in 20 for x, I
You
get
would get 30.
y of 30. So the
Oh,
coordinates are 20. In other words, that point right there would have me making 20 dozen chocolate chip and 30 dozen sugar cookies.
okay.
Now, what kind of profit does that make?
That would make, well, 20, 30. So,
Now, $20
plus,
from the chocolate chip. How much from the sugar cookies?
$30.
It's
Or,
there's 30, but you make $1.50 for each one.
so plus
45.
45.
So that profit is $65. So far,
40.
that's our best option.
Yeah.
But you have to examine all the points. So
Hmm.
let's go up to point 4 and list what the profit at point 4 is. Now, first of all, tell me what the coordinates are on point 4.
So on point 4, the,
What's the
coordinates would
y
be,
coordinate?
40. So wouldn't it be 0, 40?
Look at the x coordinate. That's not 0. This is the origin right here.
Yeah.
So the x
So,
coordinate is wherever this slanted line, wherever y equals 40.
okay.
Okay? So if I solve this inequality here and use 40 for y, it gives me an x of 10.
Yeah.
You see how? In other words,
Because,
plug in 40 into this inequality, and you get 40 is less than or equal to minus x plus 50. You solve that inequality, you get x is equal to 10.
okay.
Okay? Now, that's another combination that we're allowed. What's our
Hmm.
profit? When,
So,
when x is 10 and y is 40, what is our profit?
So let me see here. So when x is 10 and y is 40, so
Plug it into the profit equation.
yeah, so it would be 40 is less than or minus 2.
Hold on, hold on, hold on. Just take the x coordinate, plug it in for x. Take the y
Okay,
coordinate, plug it in for y, add those two numbers together.
so it'd be 40.
No, where are you getting 40? X coordinate is
What
10.
do you plug it? Yeah, plus 50, right?
Well, no, 1
Or which?
times 10 is 10. So the profit from the chocolate chips is still 10, plus 1.5 times 40, which is 60.
Okay.
So the profit there is 70. So
Which
now
is,
that point there so far is our best combination.
yeah.
One last point we have to check is this point right there. What are the coordinates of that point there?
Okay, so the coordinates at that point would be 0, comma 40.
Okay, plug in those numbers into the profit equation. So what's the profit on point 5?
Uh, so it would be 1 times 0, 0 plus 1.5 times, would be 1.5 times
40.
40. Okay, which is 60.
Okay.
Yeah.
So there's our 5 points. At this point, we made 0, this one 20, this one 65, this one 70, this one 60.
Okay.
Now the thing about linear programming is that I am now certain that 70 is the maximum profit you could ever earn here. In other
Yeah.
words, what we know is that the perfect x and y answers have to fall on one of these vertexes of this shape. Notice what
Okay.
shape, that's like a 5-sided, 1, 2, 3, 4, 5 sides in that shape.
Yeah.
So there's 5 vertexes. Now, you don't always need to test one because one almost never produces. One will usually produce the minimum, but
Mhm.
never a maximum. Okay.
Okay.
Um, and so the key on this problem
Mhm.
and the key on all linear programming problems, they all unfold exactly like this,
Okay.
is to graph it correctly
Mhm.
and then to find the coordinates of each vertex.
Mhm.
Once you have that, now you can go in and calculate the profit at each vertex. And then you choose the highest profit.
Okay.
Okay.
That
So
makes sense.
this part of the question here, the critical, yeah, let's make sure you change some of your stuff here.
Oh yeah, I changed it.
Okay,
Yeah, I changed.
cool.
Yeah, so we're all
Critical
good.
points, don't call them 1, 2, 3, 4, and 5. I did that just so I could explain it.
Mhm.
The critical points are 0, 0,
Mhm.
20, comma 0,
Uh-huh.
20, comma 30,
Mhm.
10, comma 40, and 0, comma 40. Those are the 5 critical points. That's what they mean by critical points, the vertexes of that object.
Okay, that makes sense.
Okay? Substitute the values from the critical points into the objection function. And that's what we did on the bottom half of my page over here. We
Okay.
substituted each critical point into that profit function and came out with what our profit would be if we pick one of those critical points.
Mhm. Okay.
Conclusion. So what's the conclusion?
So the conclusion would be the maximum profit of cookies sold would be 70.
More specific.
Or,
That doesn't give the information to who's cooking the cookies.
no.
I don't know how many you're going to make.
Yeah, so you'd make 70 dozen cookies and that'd be like the maximum amount of cookies you can make for that.
Hold on. The answer is, the conclusion is that you want to make 10 dozen chocolate chip cookies and 40 dozen sugar cookies for a total profit of $70.
Okay.
That's
Okay.
okay. And
Okay.
this graph down here is merely to draw the same picture that I drew here.
Okay.
Okay,
Yeah.
and you're going to want to draw this picture. Now, this was a fairly straightforward, easy problem because I had a vertical line, I had a horizontal line, and I had a slanted line. And
Mm-hmm.
sometimes, some problems you'll have two slanted lines. You won't always have just a simple situation like this. The key, probably the most difficult part of the problem, is figuring out how to find the coordinates of that point 3 that I'm pointing at here.
Mm-hmm.
In other words, it's obvious what the x coordinate is,
Right.
but to find the y coordinate, you have to plug it into this inequality and pretend it's an equation. In other words, if
Mm-hmm.
I plug 20 in for x there, I get y of 30. That's how I got the coordinates for that point.
Okay.
And the coordinates for point number 4, you got to plug in the y value that you know. I know the y value. I don't know what the x value is, but once I plug in 40 for the y value, now that tells me it's an x value of 10.
Mm-hmm.
That's what would make that an equation.
Okay, that makes
Even though
sense.
that's written as an inequality, you kind of have to assume it's an equation when figuring out the coordinates on these odd points.
Right.
Points 1, 2, and 5 are easy.
Mm-hmm.
That's 0, 0, that's 20, comma 0, and that's 0, comma 40, because
Mm-hmm.
they're part of the x and the y-axis. So the
Okay.
only 2 points that are tough to figure are points 3 and 4. And
Mm-hmm.
you got to do it just the way we did it. You kind of have to assume that's an equation.
Mm-hmm. Okay.
Okay?
Yeah, that makes sense. All right.
All right. Should we open the second page? We only have
Sure.
not a lot of time, but maybe enough that I can say a thing or two about the second.
Yeah, definitely.
And now the question is, which one was it?
Uh, that one, like the one on the right.
This is the one that had the graph on it, wasn't
It was not that one.
it? Oh, no. No, you're... tried to tell me. I just didn't listen. I'm sorry.
No, you're fine.
This is the one we just did.
No, this is a
Oh,
different
that's a
one.
new one. I saw the graph and I assumed that, okay, let's see if we can get this one set up in 6 minutes here.
Okay.
Okay,
Sounds good.
so I got to read it real quick. Expensive,
Sure.
please. In fact, I got to blow it up a little bit here.
Okay.
Okay, so tell me what the variables should be.
Oh, hold on, let me finish reading this real fast. Okay, so, x would be equal to the number of real trees, or the cost, wait. And then the number of
Now,
artificial trees for y.
hold on. Just like any word problem,
Mm-hmm.
go to the last sentence to define your variable. How many
Yeah,
of each kind should they buy? It's not cost. It's not how much
yes.
should be spent.
No, so number
How
of,
many? The number of real trees to buy.
yeah. And then the number of artificial trees to buy.
Right. And notice that it's never going to be a cost because they give you the cost in the problem. Whenever
Right.
a variable is always going to be something that they don't give you. That's what you're trying to figure out is the variables. That's why it's
Okay.
a variable. Okay?
Okay.
Okay, now let's go through some of these what's going to be the cost function, which I
Would
want
be
to minimize? In other
would
words,
it be
this is a little different problem. The last problem was we were trying to maximize profit, but this time he wants to minimize his investments. So
right?
what's the cost function?
So it'd be C is equal to um
Start from the top.
20.
Start from the top.
uh, okay, so it'd be 80x plus 160y.
There's our function that we're going to try to minimize.
Okay.
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 Now let's put our constraints. So we've just solved for the variables and the cost equation.
Yeah.
So now our constraints. The store can buy between 20 and 90 real trees. Write that as an inequality.
Okay, so it'd be up to 100 artificial trees. So could we say, huh?
X has to be greater than or equal to 20
Yeah.
and less than or equal to 90, right? The
Yeah.
policy is we have to buy somewhere between 20 and 90 real trees. So that's constraint number one.
Okay.
And up to 100 artificial trees. How can I write that? Let's look.
Up to, so that's like the max. So, equal to, um, so it would be
Y has to be what?
y has to be less than or equal to 100.
Okay. Let's keep reading. The supplier can supply between 40 and 120 trees in total.
Okay, so it'd be x is greater than or equal to 40 and then less than or equal to 120.
That's X plus Y is all of those things, right?
Oh, yeah.
The total trees we're going to buy is X plus Y.
Okay, that makes
So
sense.
has to satisfy that. Total trees has to be between, hold on, the supplier can supply between 40 and 120, but requires that the number of artificial trees ordered be more than or equal to 2/3 the number of real trees. Well, that's a constraint.
Mm-hmm.
How can I write that constraint? How do I
Um,
how do I write that artificial trees have to be more than or equal to 2/3 the number of real trees? So Y is the number of artificial trees,
mm-hmm.
has to be greater than or equal
To,
2/3
yeah,
the number of real trees.
which is x.
So Y has to be greater than or equal to 2/3 X.
Okay.
And that constraint goes along with number 3. I'm not sure. Let's see. Let me expand this. I don't think we need to read it anymore. But in order for me to try to graph it. Now, remember, we're not graphing our cost function.
No,
We're
no.
graphing all of the constraints.
Mm-hmm.
Okay.
Okay, how would you graph those?
Well, let's start. X has to be between 20 and 90. Well, X is equal to 20 there. X is equal to 90 here. So it has to be somewhere between those two lines.
Okay.
Okay, Y has to be less than 100.
Uh-huh.
There's 100. There's 20. There's 90. So now I know it has to be somewhere in between that rectangle. Has to be in this area here. Okay.
Okay.
Now we
Mm-hmm.
still have more constraints. let's do this bottom one. Y has to be greater than or equal to 2/3 x. How do I graph that?
Wait, am I missing one? Let me see. Wait.
No, for some reason this thing came up here. I don't know how to get rid of it there. Okay.
Oh, no, you're fine.
Number 4, y has to be greater than or equal. Actually, unfortunately, I have a 530 that I'm going to have to go to. So
Okay.
let me just help you here. That's the
Yeah.
slope, 2/3, goes through the origin. So it's a line like that. Okay?
Okay.
The only one we haven't graphed is that one. And you're going to have to do that. And it looks to me like that one's going to graph something like that. Okay?
Yeah.
So
Okay.
now here's your vertices. There's one. These are your critical points. So somewhere in here is the optimum answer. And once you figure out these 5 critical points, plug it into the cost function, whichever one gives you the smallest number, that's what you go with.
Okay.
Because they're
That
short
makes
on
sense.
money and they want to spend the least amount possible this year.
Okay. So
Huh?
you would start at 120. How would it go down then?
I
From
don't know.
120.
I didn't have
Oh,
time to actually graph this. I just
no, you're
guessed as to how it might graph.
okay.
And it's going to be a slanted line because
Yeah.
you have to graph it as, in other words, take your x and your numbers and move them over and graph that in 2 parts if you have to. But unfortunately, I can't explain it now. So
No, you're fine. Yeah, and I totally understand.
I will talk to you next time.
Okay. Thanks, Mr. Cowan.
All right. Bye-bye.
All right. Bye-bye.